In this lesson, we're going to positively reward our views that look at a certain landmark, like a place where the sun sets or a mountain. And we're going to do that here in the definition. And we're going to use our circle for that, because we're going to split this circle into two curves. One that's just a normal view and a small subcurve that represents the preferred view. So let me move this part a little bit down because we need some space to adjust our definition. Okay, so I'm going to use a shader curve component to do this. And we need two sliders to indicate the position where we want to shader our curve. Hold your Shift key to add more wires to an input. Nice. Don't forget to also reparameterize the curve from 0 to 1. Let me use a list item to show the result to you a little bit better. So just like that, let me turn the previous curves off. Nice. So the green curve I highlighted in Grasshopper and represented in the Rhino canvas. That's going to be the place where we want the buildings to look at. Well, ideally. And it can be wherever you want. But let's say, for example, let's say more or less here. So let me rename this into normal view. And this one into preferred view. So we distinguish them. We move this one a little bit here. This one also. So the normal view, that's going to be the new input for this component. And for a preferred view, we're not going to extrude it and use the BREP mesh component or mesh BREP component directly. We want to control the amount of mesh faces it's going to be divided in. And we're going to use the rebuild curve component for that. Now the D input, we want to change the degree into 1, so it becomes a polyline. And the N, that will determine the amount of control points and in effect how many mesh faces we're going to get. So let's say we're going to use 20 as an accuracy. And we need to add 1 to the N, so we get 21 control points, which will result in 20 line pieces. So expression will be x plus 1. So now we can use an explode curve component to get the individual line pieces. And now we can use the extrude curve component again. Nice. So now we have 20 surfaces, as you can see here in the Rhino canvas. And we can use the mesh surface component to turn them into a mesh. And we can set the U and V, which is the number of quads we want, to 1. Great. So now we have 20 individual mesh faces. So these 20 mesh faces are going to get a preferred treatment. And these ones, they're going to get the normal treatment. So they're not going to get any multiplication or anything. So now it's time to generate our factors, the multiplication factor, the reward factors. So first we need to join these two meshes into one list, not join them geometrically. Using the merge component, flatten the output. So now we have 21 meshes in one list. The first one is our big mesh. And the other 20 are the mesh surfaces. So now it's time to generate our factors, our multiplication factors. And we're going to use a slider for that. First, we need to specify how much we want to multiply the normal views, which we're just going to use 1. I think that's fair enough. And let's say we're going to use, I don't know, 5 for our preferred views. So for now, we're going to use a duplicate component, duplicate data. A little later on in this lesson, I'm going to show you a better way to do it. So the data to duplicate is 5. And the number of duplicates is going to be 20, because we have 20 faces. And we need to also add 1 to that list, which is the 1 we specified here, to flatten the output. Nice. So now we have 21 numbers. Let me show it with you with a panel. And they correspond with the 21 meshes. So the first one is just 1, because that one corresponds with the big mesh, the normal views, and the other 20, the 5s, those correspond with the preferred view. Nice. So now we need to make them also correspond with the mesh ray component. So we need to disconnect the inputs. Connect our new mesh to the input. And we need to graph these two inputs. So the P input is again going to be our point. And the D, that's going to be the normal again. But now instead of having one output, we're having 21 for each branch. And those correspond to the 21 input meshes. So let me also disconnect this component. Or better just delete it, because we're going to do it a little bit different. So a lot of those intersections are non-existent. And we're going to use the Boolean to indicate if it hits or misses to cull out the unused items or unwanted items. And we're going to use the cull pattern component for that. So just like that. So the next item we need is our 21 values, our factors. So that one goes in the L. So we also cull out those. And the last item we need is our base points, because we have our intersection points. But we also need to get a list of our base points. So we need to duplicate these points. And let's use a list length to get the amount of how much we want to duplicate them, which is 20 or 21. And we need to graph the input. So we get lists of 21, exactly like that. So we get the same tree structure. And now we're going to use the cull pattern also to cull out the unwanted items. So let me reorder this one, because these are the numbers, our weight factors. And these two are the start and the end point of our lines. So let me insert a line component to connect them again. And they go from our start point, I reorder it like this, from our start point to our end point, so like this. Nice. The only thing is we have a lot of double lines, because we have multiple meshes as an input. It can happen that a line intersects with the normal mesh, but also with the preferred mesh. So we need to sort that out using a sort list item. Let's get the length of the curve. And the way we're going to do this is by checking the line length. If you have two intersection points, we're going to choose the line length that is the smallest. So we're going to sort for line length like this. This one goes into here. And we also want to sort out with it the weight factors. So let me rename them for accuracy. So it's lengths. I'm going to call this one lines. And this one the weights. And now we just need a list item to get the first item in the list. And to wrap it up, we're going to multiply our lengths with the weight factor. And we're going to redo our lines, original lines, using that weight factor. And we're going to use a factor 2 point for that to get the direction. And a SDL line. The start point is the S. The direction is the one we just got. And the new length, that's the L. Just like that. So this part was a little complicated. My apologies. But I wanted to go fast through it because this is actually not the final way we're going to do it. We're going to use a little bit of a better approach. I'll explain that to you in a second. But as you can see, there are some views that got extremely long, as you can see now in the Rhino canvas. And that was because they hit the preferred view. And that's exactly what we want, to reward those view lines. So let me go to the top view to maybe even show it better. And let me rotate a building so you see what happens if it doesn't hit the preferred view. You see that it doesn't get multiplied, but if it hits it, you see that all of a sudden, boom, the views get way longer. The only thing is that the transition is too abrupt. Like all of a sudden, the views get multiplied by 5. And Galapagos has a hard time to determine why that was, if a change is that abrupt. So what we're going to do in the next lesson is use a GraphMapper function to kind of make this change more gradually. After that, we're going to run Galapagos to see the result and to see if the buildings are actually going to be orientated more towards the preferred view. So let's see how it turns out. Thank you for watching, and I'll see you in the next lesson.